Depending on what you're using math for, it can be very useful to understand what scientific notation is. Scientific notation is a way of writing extremely big or extremely small numbers without having a number that's literally like 6 inches long. So, as an example, in chemistry, you might recognize this number, 6.02 times 10 to the 23rd. That's the number of hydrogen atoms in a mole of hydrogen. Atoms are really tiny, so when you measure quantities of gas, you have tons of them. And rather than writing 6 with 23 zeros after it, people came up with scientific notation to just make it a little quicker to write these things. Now, I have something in this problem that says, don't use that calculator symbol E. What I'm talking about there is, when I say something like this, 5 times 10 cubed, what I'm really talking about is 5,000. But a calculator will write it this way. A calculator, if it's in scientific notation, will say 5e3. Now, that's perfectly acceptable, but it's just not going to work for this problem the way it's programmed. Okay, so just watch out for that. Let's start converting some things. So I'm going to look at this guy and say, oh, this is going to be 9.473, and then it's times 10 to a certain power. And the way you figure that out is you just say, well, how many times did that decimal move over? Started here, then I went 1, 2, 3. So 3 jumps of that decimal. And if you were to multiply, if you were to say 10 to the third, what is that? Well, that's 1,000. Then if you multiply 9.473 times 1,000, you will get this number, 9,743. So these are very easy to double check. That should not be an issue. This next one, I'm going to say, okay, well, that is going to be 1.64 times 10 to some power. Let's figure out what that power is by counting hops. 1, 2, 3, 4, 5. Now, because the decimal is going in the other direction, we have to say -5. Okay, if I did 1.64 times 10 to the 5th power, the positive 5th power, it'd be like 164,000 or something. So this was a very small decimal. We have to make sure this is a negative sign on that exponent. Now these, we're converting from scientific notation back into a normal number. So what we do is we say, okay, hop this decimal over 1, 2, 3, 4 places. What that means is this is 5, 3, 3, 4, 7 with the decimal at the end of it. And if you want, you can put a little comma in there, although I wouldn't write it that way in the answer box. The computer might get confused. So the answer is 53,347. Now this next one, when the decimal point is at 6.02, that looks fine. But the -4, remember what that means? That means the decimal is going the other way. So my decimal is actually going this way. 1, 2, 3, 4. So there's the new decimal place. And you've got zeros in between. See, I made 4 jumps of the decimal. So this is going to be equal to 0.000602. Okay, and you can always double check. It can be confusing, like losing track of the count on this. So always double check when you have an answer. Just double check and say 1, 2, 3, 4. Yep, I counted right. So that's how scientific notation works. Very handy if you're in a chemistry application, physics, astronomy, whatever. Enjoy.